Welcome back. So in this particular session, we'll try to find out the sum of the digits of a number. Let us say that consider a number like 127. Okay, so its digits are 1, 2, and 7. So the sum of this digit will be 1 plus 2 plus 7 is equal to 10. Right? And so now we're going to see how we're going to find the sum of this particular digit. Okay, so let us understand the logic first and then we'll go into the programming. Okay, so let me see here. So I've considered this number, okay, 127. So digits are 1, 2, 7, and sum equal to 1 plus 2 plus 7 equal to 10, right? So we'll take some simple concept of mathematics in order to extract this particular, each of these particular digits. So we know if we write, okay, this is not RAM, okay, so this is num. Num mode of 10, okay, let me change this num, okay, and this is also num, okay, right? So num mode of 10 means we have to find out the modulus, mean the remainder. So if I write 127 mode of 10, it will give you 7 because the remainder is 7, okay. And then if I write num divided by 10, so 127 divided by 10, it will give me 12. Right, see why I'm doing this, because I want to extract each of these digits. So first I extract the 7, and then after that I need to extract 12. So this means I need to reduce the number to 1 and 2, okay, and that can be only possible if you divide by 10. So then again again remainder num mode of 10, so 12 mode of 10 will be equal to 2, right, and 12 divided by 10 is equal to 1, correct. Similarly, again, 1 mode of 10 will be, okay, this is not 11, this is 1. 1 mode of 10 will be, okay, 1, okay, and num divided by 10, that is 1 divided by 10 will be 0, right. Then we say 0 mode of 10 is equal to 0, num 0 divided by 10. So this comes to an end. We don't require it. So you can see this is the statement, okay, right. This is the statement, and we are repeating this statement until we are finding num equal to 0. Yes or no? So we are repeating this statement. We are repeating this particular statement. Okay, we are repeating this particular statement. RAM equal to remainder, that remainder num mode of 10, then num equal to, and we are repeatedly doing this till we get, okay, num equal to 0. Till we get num equal to 0, right? So this particular problem can be solved by the loop itself. You have understood that only. Now you have seen the logic also. So logic is that we keep on doing this particular thing until and unless, okay, when num is equal to 0. But one thing is that we need to get the sum, right? So somewhere I have to create one simple, like, sum equal to here, okay, sum plus what? Sum plus RAM, right? Sum equal to sum plus RAM. So now here initially sum will be equal to 0. So 0 plus 7 equal to 7. And similarly, here also we'll put like this, okay, correct, and here also we'll put like this, right. So this particular statement will continue to do so until num is equal to 0, and then we print the sum, right. Let us come back to the code. Okay, so let int, okay, num number, great, okay, then int sum equal to 0, right. Okay, so printf enter the number, okay, so you can save it as scanf, okay, percentage d, then ampersand number, right. Okay, now what we need to do, we have this particular number, okay, right. Oh, fine, let one more thing we can do. If the number is equal to 0, okay, right, if the number is equal to 0, that we don't need to do that, we can simply write sum equal to 0 itself, okay. But anyway, let us write while, okay, so num greater than 0, okay. So now we'll have here rem, okay, equal to rem mode of 10, okay. So let me now this also rem, okay, that also I have declared, okay. Then num, sorry, we can write here sum equal to sum plus rem. Okay, yes, and next step is equal to the num equal to num divide by 10. Okay, yes, right. So you may be thinking where we are talking about the initialization, we are talking about what kind of integration. This is itself is determining this loop, right? Okay, and already we have initialized because the number we have already getting it, right? Okay, now we write printf, then we write the sum of the digits of a number. Okay, is percentage d, and then we write here sum followed by semicolon. Okay, let me save this, right? And let me now execute. What is the mistake I have done here? Number was, oh, sorry. This is anyway. Okay, RAM. Okay, fine. So let me execute. Yes, enter the number. Let us take 127 itself. And hey, sum of the digit on the number is 0. Oh, so what is the mistake that I have done? Okay, so oops, where is the mistake that I've done? Oh, see, anybody can tell me? See, while I intended that this will be sum, right? Because we're taking the modulus, okay? Right? I mistakenly written RAM. Okay, fine, great. So now I will execute it. Okay, now again execute. Number 127. Again, the sum of the digits of the number is 0. Ooh, what is happening? Oops, again I've made a mistake. So this is something very silly happening, RAM, sum, and all this in confusion. So this is now. I now will get the answer. Okay. Let me execute. So 127, it is 10, right? So let us take with another number. Let us say 367. So it should be give me 9 plus 7 equal to 16. Okay, great. So let me do some greater number. Say 1, 2, 3, 4. So it is giving me 7 plus 2, that is 9, 9 plus 1, it is 10, right? So you got this. So the very simple thing is that we need to first find the remainder, okay? And then we add the remainder, okay? Right? And then we divide the number by again 10, okay? And we'll continue this till the number is greater than 0. Yes, and once the number becomes 0, okay, the loop will come out, and then we'll have the printf, the sum of the number, okay, or sum of the digit of the number is sum. I hope it is clear. This particular concept need to be very clear, because based on this concept many programs can be, we can create many programs out of this. Okay, subsequently in the next videos I will be showing it, like palindrome of a number, reversing a number, and all these things and all. Okay, and many more are there. Okay, so this particular concept need to be very clear. So whenever you are talking or finding the digit, want to separate it, we require the concept of finding the remainder and division, right? Remainder will give me the digit out here, okay, and division will again make the number lesser so that I can get the next particular digit. Okay, right? I hope this is clear. Okay, thank you so much.